right, so in this video, I'm going to be talking about the Python basics. The slides for this in D2L, there are 20 slides, but we're only going to go through the first 13 in this video, and then we'll finish the slides in tomorrow's video. So the topics that we're covering are variables, how to store data and valid variable names, how you can read in user input to make your programs interactive, how you can evaluate expressions. So that's like doing really simple mathematical operations in Python. And there are a few different things that we'll have to talk about for that, including the order of operations, a new operator that you might not have ever heard of before called modulus, and really emphasize integer division and what that is and what it means whenever a program does that. So I'll share my screen and get started. I'm going to be going through the slides. Python basics control is what it's called in D2L. Okay, so this just kind of tells you what we'll be talking about. As far as like the control structures, like the if statements, we're going to wait and cover that tomorrow. Okay, so the first thing is talking about variables and values, data. What kind of data can you store and use in your program? So a lot of times you're going to have information that you want your program to use. You want it to be able to print out sentences and instructions. You want it to be able to perform calculations and tell you the result. You want it to be able to make decisions based on, what kind of input you get. There are all of these different commands that you want your program to be able to run and do, and they need information to do it on. They need some sort of way to store data. So we have lots of different kinds of data, lots of different values that you can have. And what the computer can do with the different types of data is really going to depend on the type of data that you're working with. So what do I mean by that? Well, here's an example. Hello world is a string. A string would be a word, a sentence, a single letter, anything that you have in, quotation marks like that. Would it make sense to say that you were going to multiply together two words or add together two words, right? That's not necessarily an operation that you would necessarily be doing with strings. And we'll talk about concatenation later. You actually can join together strings with a plus sign, but that's not addition the way we traditionally think of addition. That's a different command. So you have these different values, and the values have different types. So what these types are, int is short for integer. If you remember from algebra, an integer is a whole number. Could be positive or negative, can be zero. It's just no decimals and no fractions. So int is short for integer, and that would be like these examples 1 and 2 would be ints. A float is going to be a number with a decimal. So for example, 3.14 would be a float. And they call it a float because it stands for floating decimal. And so what that means is you could have a number, but where the decimal would be could be kind of, anywhere within those digits, because you could have 3.1415, you could have like a lot of digits after the decimal. Or for example, you could have like 12,304.9 or something where you had a lot of digits before the decimal. String, we've already talked about, that could be like a character, a word, a sentence. Bool is short for Boolean. That is a true or false value. And we'll talk about those more tomorrow. It is kind of neat that Python has this built-in command where you can say, what is the type of this data? And it will tell you, what is the type of a number with a decimal? Well, that's a float. What is the type of a true or false value? That's a bool. That's short for Boolean. Okay, and then we talked about, this was something that I mentioned in the video from earlier today, the intro to Python, it's really interesting that Python is dynamically typed. It can go through and determine what data type a variable should be based on the kind of information you give it. So if we have an assignment statement, remember that the equal sign is an assignment operator. It says, take this 17, store it in the N. What we're doing here is creating a variable, and the computer, Python, whenever it is interpreted and it looks at this statement, it's going to say while executing, oh, I need to store a 17 in N. What type of information is 17? That's an integer. So it is going to automatically make N an int. It will determine the data type for you. Not all programming languages do that. So if you took CS1 and you learned C++, when you created a new variable, you had to tell it the data type and the variable name. If you wanted to reserve some space in memory to store your information. In Python, all we have to tell it is the variable name. And then the computer will determine the data type when it sees the information, the kind of information that's being stored. So, okay, fantastic. How can we get into trouble here? You have to choose a valid variable name. And there are a few rules about what a variable name can have and what it cannot have. So we'll talk about the rules right now. Number one, it has to start with a letter. So if you have a name and it starts with something other than a letter, the computer will give you an error. It won't let you do that. It can contain letters, capital, lowercase, doesn't matter. Digits, so those are going to be numbers like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and an underscore. So if you have other characters, if you have some funky characters in there, that'll give you an error. It won't let you do it. Variable names have to be one word. You can't have spaces in between your variable name because the computer won't know how would it know what all words were supposed to be part of your name and then where new commands start and where it's supposed to be, doing something different beyond just storing your data. So start with a letter, no funky characters, all one word, no spaces. And then finally, it cannot be a reserved word. A reserved word is going to be a word that has special meaning and it tells the computer to do something specific whenever it sees it. So that would be a command, right? Or something like that, something that has some special meaning for the program. We have seen a couple of commands so far. We have seen print in the previous video. And then here we've seen type in this video. So if the computer sees the word print and it recognizes that print is a command, it tells the computer to go do these steps, follow these instructions to display something on the screen. It would not make sense for you to name your variable print because the computer would think that you were trying to give it the command, right? It would have no way to tell the difference between the two. So you cannot name variables reserved words. And if you go into the slides, there is a list of reserved words in Python that you would not be able to name your variables. So let's look at some examples of this. I'm going to go into Replit, which I showed in the previous video, and we're just going to make a couple of variables. We're going to store some information here. So if I said, for example, x equals 12, y equals 12.9, name equals Micah, because my name is Micah. One thing to note, one thing that is interesting, you can see that I have some red lines here, some angry red lines. So if you kind of hover over it, it'll tell you that's an a warning. That's like an error message. It's saying, hey, there's something here in your program that will not work. This will not run. And if you hover your mouse over it, it will tell you what the error message is. Undefined name, Micah. So it doesn't know what this is. And that's because I forgot something really important. I don't have something here that we mentioned that you need. So if you've already figured it out, good job. But if you haven't, this is something we talked about in the previous video. I have to have quotation marks around my strings. I have to tell the computer what is part of, how can I group together the text that I want to be part of my string compared to, this is not a variable, this is not a command. These are just words that I want to store as data, as information. So I have a few variables here, and let's do one with a little bit of math in it as well. Let's say sum equals x plus y. Okay. And then if I want to print these things out, I could say print x. Oh, I needed to move my arrow over to get on the other side of that parenthesis. I could say print name. I could say print sum. Can we kind of, pause here for a second and try to predict? Can we tell what the output of this program is going to be? If I hit run, can we tell what this is going to do? If I print out x, that's going to go find the variable x, and it's going to give me the value that's stored inside of it. If I say print out name, notice how there's no quotation marks here. I'm not saying print out literally the word name. I am saying this is a variable. Go find where this is stored in memory and give me the value that is inside of it. So this is going to print out Micah. What is going to be stored inside of sum? Well, sum is 12 plus 12.9. So I think it's going to say 24.9. And let's run it and do that first. Beautiful. And then we could also ask it to print out some of those types, right? What is the type of Y? What is the type of name? And then we'll run that again and we can see that command. Oh, I guess I have to print it out, don't I? So here you can see that I am nesting some commands. I have some commands inside of other commands. So it's going to work from the inside out here. First, I'm going to say, what is the type of Y? Well, Y is a number with a decimal. So that's a float. And then I say print out everything that is here inside these parentheses, print out float. So we can do that again. And now we can see 12.9 is a float and the word Micah is a string. Okay. Back to our slides. Oh, right. And we were talking about valid variable names. So let's do some that are wrong on purpose so we can see the kind of error messages that it gives us. So like, what if I said, this is my first name. So what if I wanted to call this variable first name? And notice that I have a space there. The computer doesn't know what to do with this. It knows how the assignment operator works. It knows that it's supposed to take this value and store it over here on the left-hand side. But now I don't have just one destination on the left-hand side. I have two pieces of information. That's not what the computer has instructions for. It does not know what to do with this line of code. If I hover over it, it just tells me invalid syntax, which is maybe not a very useful error message. But if I say, make this all one word, if I use an underscore to separate my two words, but they're all still combined, I have no spaces in between them, you'll notice the error message goes away. Also, we said that we couldn't include any funky characters. So if, for example, I add in like an exclamation mark, that was not a valid character, you'll see that I get an error message there. We also said that it had to start with a letter. So if I made my variable name start with a number instead, I get the angry message. And then finally, we said it could not be a reserved word. So for example, one of the reserved words we've already talked about is print. If I were to try and actually run this, I get an error message. It has no idea, it doesn't know what it's supposed to do with that. Okay. I'm just gonna. Oh, and here is a really good point. This is a very common mistake that beginning programmers make. Notice here, if I called my variable first name up here, now I get error messages every time I have the word name down here because name was not created anywhere. Name has not been defined. I defined it as first name. There is no variable called name anymore. And so the computer doesn't understand what that is. I need to make these match. I could either go through and make them all first name, or I could have gone back and made my original name, as long as they're the same. Perfect. So here we have just some statements. Remember that Python is interpreted. So it's going to execute just like one line at a time. It's just like going to send an instruction, execute it right away. It'll translate it and run it right then, come back and get the next instruction. Okay. If I tell it to, yeah, we've seen this before. So this would print out a 1 and then print out a 2. You can change the data that is stored inside of a variable. That's an important concept, right? So just like in math, when you have a variable and the information inside of it can change, we can use the variable x to represent lots of different numbers, right? I could do the same thing here. So let's say, I'm going to take all this out. If x equals 12 and I print x, we expect that I'll get a 12. I can change and make x equal 90. And now when I do the exact same command, it's going to print out, the first one is going to print out 12. So like whenever a computer runs your instructions, it reads them like a book, starts top to bottom, right? It's going to go left to right, top to bottom. So it's going to start here with line 1. The very first thing it did was put a 12 in x. When I print x right now, x has a 12. And then I'm going to ask it to put a 90 in x. I'm going to overwrite the data that was stored inside of there. So now the memory location where I have a variable called x and it's storing data for me in the computer, now if I print out, well, what's inside of x, it's going to have a 90 because I overwrote the value that was stored there, right? You can change what is inside a variable. And the result, whatever you're going to have, is going to depend on what is stored inside of there right now at this point in time. So that's an important concept too, the flow of control that we have for execution. All right, so now we're going to, we've talked about the basics and the valid variable names. We're going to go through some expressions now. So I've shown you a couple of examples where you can do math in Python, that it will do some math for you. These are the operations that we have. It can add, subtract, multiply, and divide. And the double multiplication signs, 2 of them, 2 asterisks right next to each other, is going to be an exponent. So that would be like, 3 raised to the power of 2 is 9. This would be how you would represent to the power of in Python. Okay, so you have operands, you have operators. Okay, and this is we're going to talk about mod and integer division both. Okay, these are some big concepts. I'm going to go ahead and talk about mod first. Modulus, sometimes people call it modulo and sometimes people call it mod, but it is represented by the percent sign. And this is the remainder operator. The way it works is you take the first number, you divide it by the second number, and it returns the remainder. So the result of the division, that quotient answer that you get when you divide, nobody cares about it. No one's interested in how much it is whenever you divide. The only thing that the mod operator is keeping track of is what is the remainder. It's used a lot more often than you might think. I remember when I first learned about mod, I was like, well, what's the point of that? But once you kind of write some programs, you can see lots of applications for it. So in this example here, we would have 7 divided by 3. Well, if I did 7 divided by 3, it would be 2. 2 times 3 is 6. I would have 1 left over, right? I would be 1 away. And then I'm going to come back up here and talk about integer division, because integer division is also going to behave differently in computer science than it does in math. You divide differently in programming than you did when you were learning how to do it previously. So I want to really emphasize this. It's easy to forget about it because it's not something that we've grown up doing. So it does require kind of a little bit of different way of thinking. Integer division is the idea that when you are dividing one whole number by another whole number, the computer looks at that and it says, oh, this person is working with whole numbers. That's how they want their information. I'm doing integer math. So my answer will be a whole number as well. And even if in reality, the quotient, the result of that division should have had a decimal with it, the computer will just chop it off. It's called truncation. It'll truncate it. It does not round. It doesn't ever even consider it. It doesn't even calculate what the rest of that division would be. It just gets the whole number part of it and then ignores everything else. It just chops it off. So people make a lot of mistakes around integer division in computer science. If you have a whole number divided by a whole number, the answer is only the whole number part of the result, and any decimals are just ignored and forgotten about. So here's an example. 59 divided by 60. Well, in reality, that's almost a whole. It would be, I don't know the exact decimal, but it would be like 0.9, something very close to one whole. 0 point something. If all I'm doing is retaining the whole number part of it, the 0 is the only part that I keep, just the whole number. So if I said, if I was doing, and I'll show you an example of it instead of just talking about it. If I said, I'll come do it over here in the console. What is 3 divided by 4? 3 divided by 4 is 3/4. It's 0.75. But if I'm in Python and I want to do integer division, I can do the double division signs and it will do integer division instead. So if I say, what is 3 divided by 4 in integer division, all I get is just the whole number aspect of it. I only get the 0. I do not get the 0.75. And notice it didn't round up, right? If I was rounding, 0.5 would round up to 1, but it doesn't. You only keep the whole number and you chop the rest off. So that was a lot of information on this slide. Oh, and I guess I can go ahead and show you an example of mod as well. So remember the way mod works. Mod is represented by a percent sign. It divides the two numbers and it returns the remainder. So some examples of that. If I had 6 mod 2, 6 divided by 2 is 3. Nobody cares about the 3. What is the leftover part? There is no leftover part because it divided evenly. So the remainder of 6 divided by 2 is 0. If instead I did 5 mod 2. 5 divided by 2 would be 2 with a remainder of 1, right? So I get the remainder back when I do the modulus operator. Okay, so that was a lot of information on that one slide, but the idea is that you can do math, you can evaluate expressions in Python in your programs. You can use some of these different operators, know what addition, subtraction, multiplication, and division are, and the modulus operator. Know that double asterisks means an exponent, and double division signs do integer division. You're for sure going to see something about that on your quiz. So make sure that you write that down in your notes, make sure that you practice with it a little bit, open up Replit and just sort of type some code in and see what kind of results you get back out. Playing around with programming is a great way to learn some of the rules and see kind of the behavior that you get out of it. Okay. So an expression is going to be your values with your operators. You can type it in directly and it will give you the answer. It is going to follow the traditional order of operations. And I didn't make these slides, I didn't write them, but I need to go back in and add an M in here because it is really PEMDAS, because we have to remember we have another operator. We have modulus in here. And the modulus is going to have equal precedence with the multiplication and division. So if it's been a little while since you've had algebra and you don't quite remember your order of operations, we have P is for parentheses. The very first thing you would evaluate is whatever is in parentheses. Second, you would do your exponents. Multiplication, division, and modulus all have equal precedence. So you just read them left to right, just whichever one comes first. And then addition and subtraction have equal precedence. So again, it's just whichever one comes first when you read it left to right. Okay. Yeah, we've talked about how you can find the type of different variables, and we've talked about how you can print them out to see what the type is. And then our big thing that's going to mess some people up when you write your programming assignment today is that sometimes you need to specify a specific type, a specific data type that might be different than what the computer automatically assumed. Okay. So you can do that by writing the type you want it to be, the data type you want the information to be, and then you put parentheses, and then whatever you want it to cast goes inside the parentheses. So whatever value you want to change the data type of would go inside these parentheses. Why would you maybe want to do that? Well, I will tell you why. We are going to read in information from our user. We're going to make an interactive program where we can do results, we can make decisions, we can print out answers based on what the person using our program typed in. When you read in information, I'm going to go one more here. When you read in information in Python, it is always read in as a string. That's very important. I think it's in big red letters on the next slide. But whenever we use the command, this is a new command, we haven't talked about it yet. The command is input, and it's used to get information from the keyboard. If I say input, whatever goes here is the prompt that gets displayed on the screen so that the user understands what I want them to do. And then it's going to read in their answer. It's actually going to pause and wait for the person running the program to type in a response. And then it will read in the response and it's going to store it here in this variable. The catch, the big thing to know is it's always going to get stored as a string. And sometimes that's not what we want. If you want to be able to do math with whatever you're reading in, you're going to have to use casting. You're going to have to come back and cast and say, no. I don't want to read in, the number 5 as like a word, 5. I want to read it in as a number, as an integer, or as a float, so I can do math with it. Implicit casting is whenever Python does it itself. We actually saw an example of that earlier when I asked the computer to do 12 plus 12.9. Those two variables, those two values had different data types. So when the computer was like, well, how do I do math with an integer and a float? It did this implicit type conversion. It automatically made the integer into a float. It promoted it. So I had 2 of the same data type, 2 floats, and it was able to do the addition and get that the result was 24.9. Explicit casting is going to be whenever we, as the programmer, say specifically, I am telling you, I don't want you to decide for me, I am telling you the data type that this information needs to be. And one big reason that you guys are going to do that in your program is because when you read in an answer using input, we might want it to be a number. And here's an example of how you could do that right here. Let's take a look at what this line of code is doing. Print out, how fast were you going? Those are the literal words. That'll be the prompt that's printed to the screen. Read in their answer. So I'm going to get the result of whatever they typed in, whatever the user typed in. Cast their result as an int. Take the information that you read in and change the data type. Instead of treating it as a word, I want to treat it as a number. Store that number in the variable speed. So I get the result. This is my assignment operator. I take that value, I store it in the variable speed. Okay. And this is the thing, it's bold, it's red, it's big, there's lots of asterisks. Like, this is really, really important. Write it down, highlight it. You are going to get an error in program 1 if you are not careful about this. Input returns a string. So if you ask for a number and it gives you the number 5, fantastic, all good, until I start trying to do math with it, right? If I start trying to add it, it's going to say, I don't know how to add a word plus 5, right? If I said to you, what is house plus 5? What's the answer to that? You wouldn't have a good answer to that because there's not, like, it's not clear what you're supposed to do in that situation. We don't have clear instructions for how to say house plus 5. So if I want to be able to do math, I need to cast it as an int. Okay, this is our last slide and our last topic for today. Comments. A comment is information that we type in a program that is not part of the instructions. It gets ignored by the computer. It's not going to get translated to machine code. It's not going to be interpreted. The computer is not going to execute it in any way. These are notes that we make for ourselves. Comments are notes that you can put in for a program that help make the program more readable, more understandable. And we use them for lots of different ways. In class, we are going to use them to put headers up at the top of our assignments. You can have a comment heading with your name and your class and the date and all that. We also use comments to describe what's happening in a program. When you're writing code and you get it working, and it might have taken you a little while to get it working, and you leave and go do other things and then come back to it a few days later, maybe a week later, maybe a few months later, you can absolutely have forgotten what you were doing at that point in time. You could forget why you wrote it a certain way. You could forget what kind of errors you got or how you solved them. You know, you could forget what a certain variable was doing, what its purpose was. You use a comment to help explain what is happening in the program, and then other people can read your code and understand it, and you yourself can read your code and understand it. We use a hashtag or a pound sign or whatever you call this, probably depending on your age, to make a note that is not ran. It's not part of the instructions. It's just there as a note to the programmer or anyone else reading the assignment. Okay. So let's do just an example of that. So if I said, you know, if I was going to maybe put like a little comment heading up at the top of my code, so I could say like name is Micah Morgan, and the course is CMPS 1023, and the term is summer 2, 2022. Sure, why not? If I hit run, none of this information got printed out. The computer didn't do anything with it. It didn't change anything at all. You might notice that it kind of grayed it out a little bit. That's just visually trying to help you see that this is not part of the program, in the sense that it is not a command that's going to be, you know, read and used. You might also be able to tell there's a little bit of, you know, color differentiation for the commands, the built-in commands that I have typed here. So if you make a typo, it can be easy to tell if it doesn't change colors. That can be a clue to you that maybe you didn't really use the word like you intended to. So let's see getting input, and then we'll call it a day. That'll be all the content for Monday. So let's say I'm going to use the command input. I have to print out my prompt. And look, it's even telling me here, what goes inside the parentheses? Your prompt. What do you want to be displayed on the screen so that the user knows what kind of information they're supposed to type in? What is your favorite color? And we're going to store it in color. And then what do I want to do with that information? I am going to print out the literal exact words. I like the color 2. Okay. What I want, the result I am trying to achieve is I want to print out that I also love their favorite color, but I'm trying to embed the result in here. I'm trying to include whatever response they gave me in my answer back out to them. So that's an interactive program, right? The user is going to enter in information, and then what my program does is going to depend on what they entered in. Now, I can't hard code in the color here because I don't know what their answer is going to be. I want it to print out these exact words, and then I also want it to print out whatever value is stored inside of this variable, right? So how do I get it to join that information together? I want it to print out both of them. We are going to use something called concatenation. We're going to use the plus sign for that. And what I'm telling the computer is not add. I'm not, this is not the same thing. It's like 3 + 8. I'm saying join together these strings one right after another. Print out, I love the color and a blank space. Actually, Python might put spaces in there automatically. I might not have needed that. And then right after it, print out whatever is stored inside of color. That's going to be whatever answer they gave me. And then join on to that the end of my sentence. So let's see if I needed those spaces or not. What is your favorite color? I want a space after the question mark. I don't like the cursors right there. My favorite color is yellow. I love the color yellow too. Well, of course you do, because I'm the one that said it, right? But let's see if I needed the spaces there. Let's say that my favorite color is blue. Okay, I did need them. Fantastic. So if you're noticing that, if you do this, if you use concatenation and your words are all, smooshed up together, remember that it is going to print exactly what's in the quotation marks. So you might need to include some blank spaces inside your quotation marks so that your end result that it prints out looks really nice. So one final time, what's your favorite color? Red. I love the color red too. Every time I run this program, this second sentence that prints out is going to be different because it's going to use whatever they typed in right here. If I tried to type in some kind of math, if I said like, what's your favorite number? And then I tried to multiply it by 2, I would get an error. It would not let me do that. It would not let me do math with it unless I did this right here. I would have to cast it as a number. Do not forget to do that when you're writing program 1. So that's it for today. It was quite a lot. Hopefully I didn't completely overwhelm you. There was a lot of information to get through to start up Python, but we do have a quiz over Python basics, and the quiz covers valid variable names. Make sure you know the rules. Reading in user input. We covered that a few times. And evaluating expressions. It's going to ask you what the answer to some of these math questions would be. It's fine for me if you want to use a calculator. That's totally okay. I'm not worried about that. What's more important is that you understand how the expressions are evaluated. And what you really need to be careful of there, is that you follow the correct order of operations. PEMDAS. That you remember integer division. If it happens, 2 whole numbers divided together with those double slashes is going to give you a whole number result. And the modulus operator, which is brand new. You might want to practice with it a little bit and make sure you understand that one well. That is all that I have for today. So I will see you tomorrow, and maybe I'll see some of y'all on the Zoom call today if you have any questions.